How do people usually describe planets? Massive, freezing, boiling hot, seismically active. Let's admit it, shiny is not normally on the list. Unless we're talking about a world called LTT 9779b, which might be the shiniest planet we've ever seen. This exoplanet, which is basically any planet outside our solar system, is ultra hot and acts like a giant space mirror because it's covered with a thick layer of reflective metallic clouds. This unusual world is located about 264 light-years away from our planet. And the most amazing thing about it is that it reflects approximately 80% of all the light its parent star sends its way. For comparison, Earth reflects a mere 30% of the light it gets from the Sun. The bizarre exoplanet is even more reflective than the shiniest planet in the solar system, Venus, which reflects around 75% of sunlight due to its thick clouds. LTT 9779b is 5 times as large as Earth, which makes it the largest space mirror ever discovered. By the way, this world was found by NASA's Transiting Exoplanet Survey satellite mission in 2020. But the highly reflective nature of the planet was uncovered later thanks to a follow-up investigation conducted by the European Space Agency Exoplanet Hunting Spacecraft, CHEOPS, which stands for Characterizing Exoplanet Satellite. Now, imagine a planet the size of our ice giant Neptune. It's a burning world floating close to its star. If you stepped on its surface and looked up, you'd see heavy clouds of metals floating over your head, raining down titanium droplets. The planet's size, coupled with its insane temperatures, allow astronomers to classify the planet as an ultra-hot Neptune. Now, a planet's high reflectivity is a quality known as albedo. And in the case of our shiny world, its albedo mystifies scientists. All because most planets that are not ice worlds, or planets with thick layers of reflective clouds like Venus, normally have low albedos. Their atmosphere or surfaces simply absorb the light coming from their stars, preventing it from getting reflected back into space. And initially, researchers were sure that LT 9779b would have a low albedo. After that, by no means was it an ice world. Not with the surface temperatures reaching 3,650 degrees Fahrenheit on the side of the planet permanently facing its parent star. It was supposed to be too hot for water clouds to form. Even clouds of metal or glass wouldn't be able to form in such a scorching climate. Astronomers expected a planet like that to have its atmosphere destroyed by its star, which would leave behind a lifeless, rocky world. That's why discovering metallic clouds was so unexpected. Of course, researchers were eager to find out how such clouds could have formed. It had remained a mystery until they decided to think about the cloud formation in the same way as condensation that appears in the bathroom after you take a hot shower. There are 2 ways to steam up your bathroom. You can cool the air until the water vapor condenses, or you can keep hot water running until clouds form. It will happen when the air in the bathroom becomes so saturated with vapor that it won't be able to hold it anymore. So, researchers came to the conclusion that most likely the atmosphere of the shiny planet became oversaturated with silicate at one point. And then, metal started vaporizing due to boiling hot temperatures on the permanent day side of the planet. But if you think that the reflective nature of LT 9779b is its only unusual feature, you might want to hear this. The exoplanet is an example of an extremely rare planetary type, and ultra-hot Neptune. Astronomers have been searching for such planets for decades, but those preferred to remain a mystery. The fact that the planet survived so close to its star might be linked to its high reflectivity. Some experts believe that the metal clouds covering the planet probably reflect light and prevent the planet from overheating and evaporating. Plus, such a highly metallic atmosphere is much heavier and harder to blow away than any other. Now, about 850 light-years away from Earth, a planet called WASP 121b orbits its star. This planet is a hot Jupiter, which means it's a gas giant moving very close to its star. And because of such a short distance, the planet is also insanely hot. The average day temperature there is around 5,000 degrees Fahrenheit. Interestingly, just like our previous shiny world, this planet also has metallic clouds floating over its surface. But that's not the only oddity. WASP 121b has a bizarre oblong shape. Can it be because the planet is tidally locked to its star? It means that one of its sides always faces the star, while the other is always turned to the darkness of the cosmos. In other words, it's always daytime on one side of the planet and nighttime on the other, which causes crazy temperature differences. Researchers think it might be the reason for the metallic clouds. The water cycle on WASP 121b is also pretty bizarre, to say the least. On the illuminated side, the atoms that make up the planet's water get ripped apart by the insane temperatures. After that, they get blown by winds moving at 11,000 miles per hour to the other side of the planet. There, much lower temperatures allow the atom to recombine into water molecules. At the same time, the nighttime side is cold enough for metal clouds consisting of iron and corundum to form. When these clouds migrate to the daytime side of the planet, they vaporize and rain down metal on the planet's surface. But if these clouds don't seem impressive enough, I've got more. Astronomers predict that the planet will rip itself apart in the next several million years because of its incredibly fast winds and wild temperatures. Plus, the gravitational pull of the planet's parent star also plays its role in this dark prediction. Since WASP 121b is so close to the star's gravity pulls the planet into a weird oblong shape and makes gases like iron and magnesium leak from the planet's atmosphere. This pull is so strong that the planet is always on the verge of a tidal disruption. If it ever happens, the planet will come apart for good, metallic clouds and all. Just 20 light-years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming our home Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's magnetic field. The exoplanet also produces amazing auroras. When it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf, which is an object too large to be a planet and too small to be a star. But later, scientists got some proof that the space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet of the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptionally strong magnetic field helps the planet produce the auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create these light shows. Another planet you probably shouldn't set foot on is WASP 76b. There, it rains iron on the night side of the planet, and the temperature on the daytime side rises up to 4,300 degrees Fahrenheit. That's hot enough to vaporize most metals. This exoplanet is a bit larger than Jupiter in terms of size and is located 640 light-years away from Earth. Such terrifying weather conditions in this world are caused by its unusual orbit. The distance between the planet and its parent star is 10 times shorter than the distance between Mercury and the Sun.
Okay, here you are in the middle of the ocean. It's endless, but you can't see it because there's a thick fog all around you. Dense clouds hide the huge but dim sun. Is it day or night? You don't know. There's only a gray haze around you. You're alone. Even if you try to swim down, after several hours, you still won't be able to see the bottom of the ocean. And that's a typical water planet for you. I know, sounded kind of dark, but it's not that bad. These water worlds are more interesting than they may seem, so let's take a look at them. The ocean planet is a planet that consists, as you might have guessed, mainly of water, ice, and maybe some rocks. Think of the Earth's oceans. Its horrifying depths, the Mariana Trench, and all that. And now, can you guess how much space all the water on Earth takes up? 0.025%, exactly. Now, just try to imagine a world of 40 to 60% water. If you dive in there, the depth can exceed 60 miles. Compared to that, the 6-mile depth of our Mariana Trench sounds like nothing. And yeah, the pressure there will be enormous. It can reach up to 20,000 Earth atmospheres. Very crushing. Now, it may sound scary, but it still would be great to find out more about these planets. Fortunately, according to scientists' calculations, there may be a lot of such planets in our galaxy alone. Well, you don't have to go far. You can find these water guys even in our solar system. Not planets, of course, but moons. Jupiter has Ganymede and Callisto, and Saturn has Titan and Enceladus. The ocean can reach up to 30% of the mass of these moons, although it isn't clear whether these oceans are covered with a thick crust of ice. But we've discovered quite a few full-fledged ocean planets. This is because the conditions in which these planets may exist are very specific. For example, this planet should be somewhere 6 to 8 times larger than the Earth. If it's smaller, it'll have a rocky surface, but if it's bigger, it'll turn into a gas giant. At the same time, it must be in the habitable zone of its star. A little further, and the planet immediately turns into an icy giant or a cold super-Earth. So yeah, these guys are very picky. We first started exploring these planets back in the 1970s. However, since then, we found only a couple of them, but they're still very interesting. The first planet is Gliese 1214b. It was the very first ocean planet that we discovered. Initially, the scientists noticed only a small dim dot. This dot turned out to be the red dwarf star Gliese 1214, an unremarkable, completely ordinary star that's 5 times smaller than our Sun and 300 times dimmer. Scientists wouldn't worry about it at all, but back in 2009, they noticed that this star had one single planet, and this planet turned out to be quite strange. This super-Earth was 2.5 times bigger than our Earth and 6.5 times heavier, but at the same time, it had a very, very small density and about the same gravity as our planet. In other words, there were almost no rocks and metals on it, but it wasn't a gas giant either. So there was only one option left. It was covered in water and ice. And that's how we discovered the first ocean planet. Well, actually, we can only assume that it consists of water. That's what the mathematical calculations say. In reality, this planet is quite confusing. It's difficult to explore, and so far, scientists haven't been able to find anything there. No hydrogen, no helium, no water, nada. That's because the outer layer of the atmosphere of this planet is very dense, and it perfectly hides its composition. But even so, it's probably a water world. Gliese 1214b is very close to its star. It's only 0.014 astronomical units away, which is less than the distance between the Moon and us. The year there lasts about 36 hours, and the temperatures, to put it mildly, are just wild. Scientists suggest that the average temperature there can reach 250 to 535 degrees Fahrenheit. Woo, that's hot. Remember the creepy description from the beginning? Well, actually, spending time on Gliese 1214b would be a little different, more like swimming in a steam boiler. Because of such gigantic temperatures, the ocean on the surface will be constantly in a state close to boiling without actually reaching it. So, imagine that you're descending to the surface of this planet, flying through clouds of steam, and then you suddenly find yourself in the water. What? But when did it happen? Well, that's because the boundary between steam and water on Gliese 1214b will be very blurred. Of course, you won't be able to swim to the bottom of this ocean, but most likely, this bottom is covered with a very thick layer of so-called hot ice. It's like regular ice, but it doesn't really care about the laws of physics, so it just doesn't melt even at gigantic temperatures. And the thickness of this ice can reach as much as 3,000 miles. So that's it for the creepy Gliese 1214b, and not an Airbnb in sight. Now, although we can't 100% guarantee that it's a water world, we still have another candidate for this position. A newly discovered planet called TOI 1452b. This planet, located in the Dragon constellation, is almost 100 light-years away from us. It was discovered using the TESS telescope by a group of researchers from the University of Montreal. This planet also belongs to the class of super-Earths. It's 7 times larger than our planet, but 48 times heavier. Again, all this is at a very low density. Because of this, scientists have suggested that almost the entire planet consists of a giant ocean. Here, we were a little luckier. This world won't be just a giant puddle and some thick ice. On this planet, there's probably a rocky surface deep under the water, just like in a typical ocean. Don't get too excited though, this ocean will certainly be very different from what we're used to. TOI 1452b also orbits a small red dwarf, and not even one, but 2 at once. At the same time, if the previous planet was close to its sun, then this one, on the contrary, is very, very far away. It's 2.5 times farther from its stars than Pluto is from the sun, and it moves at great speed. A year there lasts only 11 days. But we still don't know many things about this planet. We'll probably get some new information when scientists observe it from the James Webb Telescope. Well, that's it. Wait, did you expect something else? Alright, I know the question that bothers you the most. Can there be life? Well, this is a difficult question. We all know that water means life, and besides, these planets are in the habitable zones of their stars. So, potentially, yes, there might be life. Not some full-fledged civilizations, of course, but bacteria, fish, and some creepy giant monsters. I mean, why not? However, this is very unlikely. Water alone isn't enough to create life, even though it's very important. There should also be some microelements and some minerals. And unfortunately, for most water planets, the composition will only consist of water and very thick ice. There won't be any minerals there. But don't give up. There's still some probability. First of all, there are meteorites and comets. They can bring the necessary minerals to the planet. The more often they crash into it, the higher the probability that they'll bring something like this into the ocean and thus create life. Secondly, TOI 1452b actually has these minerals. Yes, we don't know how deep the rocky bottom is located there. But if it exists, then surely something could have originated there. Let's hope that new research with powerful telescopes will allow us to find out the truth. And who knows? Maybe one day we'll be able to visit such a planet ourselves. At first, it may seem like the sun is burning, but it's actually not true, because the burning of our star isn't chemical combustion, it's nuclear fusion. The sun can't run out of oxygen or stop burning because it doesn't use oxygen to burn. Regular carbon combustion requires oxygen. As soon as there's no oxygen, the process of burning stops. Now imagine a candle. If you cover it, it doesn't have access to oxygen anymore, and the process of burning stops. But in nuclear fusion, the nuclei of atoms are fused together to make new, bigger nuclei. Such changes cause atoms to become new elements. Nuclear fusion doesn't require oxygen or any other material altogether. You just need enough pressure or heat to squeeze the nuclei of atoms close enough for them to overcome their electrostatic repulsion and bond into one nucleus. In 2027, 2 teams of astronomers discovered a cloud of water floating in open space. It was the largest and farthest reservoir of water ever detected in the universe. It's a cloud of water vapor surrounding a huge black hole called a quasar, 12 billion light-years away from Earth. The environment around the quasar must be unique to somehow produce such giant masses of water. It was formed by energy waves colliding hydrogen and oxygen atoms together. The cloud contains 140 trillion times the entire volume of water on our planet. It could provide each person on our planet with a planet's worth of water 20,000 times over. Wow! Even cooler, astronomers believe this water cloud appeared just 1.6 billion years later than the universe itself. Scientists consider it another demonstration that water exists throughout the universe and was present already during its early days. At the same time, before this discovery, scientists had never found water vapor present so far back in the early universe. There is water in our home Milky Way galaxy, but most of it is frozen in ice. Not only water is floating out there in space, alcohol too. In 2009, scientists were examining a massive cloud of gas and dust in the center of our galaxy when they stumbled upon a surprise. There was ethyl formate within the cloud. This chemical is responsible for the sweet flavor of raspberries. They also found one more cool region. This one was brimming with ethyl alcohol, the same type found in many beverages. At the North Pole of Saturn, a mysterious storm is raging. It's ginormous, spanning an area larger than our planet and showcasing a beautiful but baffling hexagonal pattern. No one has understood yet why the storm has such a bizarre shape. After the hexagon was first discovered in 1987, it remained hidden in darkness up to the moment when sunlight exposed it again. Soon afterward, the Cassini spacecraft, designed to explore the Saturn system, provided a series of captivating images and even a video of the hexagonal storm. It turned out to be colossal in size. Its estimated depth is around 180 miles, and the eye of the storm is 50 times as large as the typical storm on Earth. The storm is also changing its color from blue to gold. Winds of hydrogen and ammonia surround the storm and move at more than 300 miles per hour. The storm has several centers. Some of them move clockwise, and others follow a counterclockwise direction. The largest vortex appears to be white, and it's twice larger than the standard hurricane on our planet. As for the hexagon itself, it's a jet stream made up of atmospheric gases. Experts refer to it as just a current of air and weather features. But there is one intriguing detail: a vortex sitting at a higher altitude than Saturn's clouds. It looks like a large towering structure. Saturn's auroras, triggered by the planet's magnetic field, are located atop of the hexagon, giving its appearance a mystical vibe. Astronomers have found a giant, likely active volcano near Mars's equator. It was literally hiding in plain sight. It's ancient and deeply eroded, but seems to be still functioning. There may even be remnants of a glacier ice near its base. That's why this discovery might indicate a promising new location to search for life, as well as a potential destination for future human and robotic exploration. The structure is still awaiting its official name. At the moment, it's referred to as the Noctis volcano. It reaches a height of 29,600 feet and spans an impressive 280 miles across. Such a giant size indicates that the volcano has been active for a very long time. In its southeastern part, there's a thin, recent volcanic deposit, and beneath, glacier ice might still be present. At a distance of 700 million light-years away from Earth, there's a gaping hole. A blank void with no galaxies, stars, planets, or asteroids. Literally nothing. The void is a roughly spherical region about 330 million light-years across. Our home Milky Way galaxy could fit there billions of times over. That's the mysterious Bootes void. It lies in the constellation of Bootes, the herdsman driving the plow around the North Pole. At first, this void had the name of the Great Nothing, but later it was given its current name. Now, we know that galaxies look like a giant web. Most of them are parts of long structures called filaments. Those wind through the cosmos, and when they meet, they form regions with a high concentration of galaxies. These regions are what we know as galaxy clusters, but between these clusters and threads, there are enormous empty voids that hardly contain any galaxies. Such voids actually make up almost 80% of the observable universe, and most of them are huge, from 30 to 300 million light-years wide. The Boots void is one of the most massive ones. It has even earned the title of supervoid. Astronomers think it might be the result of a few smaller voids merging together. There is a diamond planet out there that orbits a star in the constellation of Cancer, completing one full rotation in a mere 18 Earth hours. The planet's scientific name is 55 Cancri e. The radius of this faraway world is twice as large as Earth's, and its mass is 8 times greater. The planet is scorching hot, the temperatures on the day side reaching almost 5,000 degrees Fahrenheit. But the coolest thing about 55 Cancri e is that, according to some specialists, at least a third of the planet's mass could be diamond. That's the equivalent of around 3 masses of our home planet. Sounds like big money floating out there in space. How about we calculate how much this planet could be worth? Wait, someone has already done it, and the number is astronomical, pun intended, of course. It's 26.9 nonillion, and if you're confused by this number as I am, that's 26.9 followed by 30 zeros. Now, for comparison, one of the most expensive diamonds on Earth ever is the Cullion. It costs a whopping $2 billion, and its original weight was a mind-boggling 3,106.75 carats. It was, and still is, the largest raw gem diamond ever found. Later, it was cut into many small diamonds. The largest of them is Cullion 1, which also goes by the name of Star of Africa. It has a carat weight of about 530, but imagine how much bigger and more expansive the Diamond Planet is. Nebulas are gigantic clouds of gas and dust, and some of them can have really unusual shapes, as if they were made this way on purpose. With time, gravity starts to pull these clumps of dust and gas together. They grow larger and larger, and their gravity gets more powerful. One day, this mass becomes so big that it collapses under its own gravity and forms new stars. Among some of the most beautiful nebulas out there, we must mention the Butterfly Nebula. Its wingspan is more than 3 light-years, and the structure inside the nebula is one of the most complicated ever observed. The central star, a white dwarf, is heated to an incredible 450,000 degrees Fahrenheit. It means it formed from a giant gargantuan star, likely more than 5 times the size of our Sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. It's what probably makes the whole structure look like an hourglass or a butterfly. The Ring Nebula looks like a giant cloud of dust and gas surrounding an old, almost extinguished star. At first sight, it does look like a ring, but astronomers say the nebula isn't a bagel, it's a jelly-filled donut. They must be hungry. The deep space colorful object, more than 2,000 light-years away from Earth, is actually a ring that wraps around a blue ball-shaped structure. Each end of the structure sticks out of the ring's opposite sides. The pillars of creation look like something out of this world. See for yourself. They're located 7,000 light-years away from Earth in the Eagle Nebula. That's a young cluster of stars just 5.5 million years old. On a space scale, they're just babies. Once, the Hubble Space Telescope managed to take an image of several dark silhouettes near the nebula's center. And now you can see them with your own eyes. Those are the so-called pillars of creation, an active star-forming region. Look at this famous image. The blue colors represent oxygen, red is sulfur, and green means the presence of both hydrogen and nitrogen. The pillars are also bathed in the ultraviolet light coming from a nearby cluster of young stars. Unfortunately, the winds from those stars are slowly but steadily eroding the magnificent towers of gas and dust. Far out in space, a ghostly super-ancient galaxy is floating all alone. It shines with a faint glimmer of starlight and has hardly changed for billions of years. Astronomers have no idea why it's there or how it formed. Meet DGSATI, a living fossil galaxy. It's as big as the Milky Way, but is nearly invisible because its stars are spread out incredibly thinly. But what makes the galaxy so unique is that it's sitting all alone, unlike other galaxies of this kind, which are usually found in clusters. It might mean that DGSATI was formed in a different era, probably a mere 1 billion years after the Big Bang. If it's true, the galaxy is a real living fossil. Astronomers have discovered the most massive stellar black hole ever spotted in our home Milky Way galaxy. This newly found space monster is 33 times bigger than the Sun and sits 2,000 light-years away from us. Until recently, the largest stellar black hole found residing in our galaxy has been around 20 times as big as our star in terms of mass. As for the average stellar mass black hole, it's usually about 10 times as hefty as the Sun. Scientists spotted the giant black hole after a star started to wobble while orbiting in that area. The black hole got the name of Gaia BH3. The proximity of this space object to Earth makes it the second closest to our planet black hole ever discovered. The nearest one is called Gaia BH1. Makes sense. It's hanging out around 1,560 light-years away from us. This uncomfortably close neighbor has a mass of around 9.6 times that of the Sun. That means it's way smaller than the newly found black hole. Gaia BH3 is located in the Aquila constellation. From Earth, it seems to have the shape of an eagle. Interestingly, astronomers didn't expect to find a high-mass black hole lurking so relatively close to Earth and remaining undetected for so long. Now look at this marvelous exoplanet. It resembles a giant eyeball hanging out there in space. But it isn't the coolest thing about it. This distant world, identified in 2017, is one of the most promising places for finding life outside our solar system. The exoplanet is called LHS 1140b, and it shows signs of having a global ocean capped in ice. It's that very iris, a huge region around 2,500 miles across, which is constantly gazing at its host star. The planet has a radius of about 1.73 times the radius of Earth, and is 5.6 times as massive as our home planet. The giant eyeball planet orbits much more closely to its star than Earth does. It needs just around 25 days to complete an entire orbit. If the star were similar to our Sun, such a distance would definitely be too close for life to appear on the planet. But instead, it's a cool and dim red dwarf. That's why the exoplanet lies in the habitable zone of its star, where it's not so cold that all surface water would freeze, and not so close that this water would steam away. At the moment, LHS 1140b looks like the most promising candidate for hosting life in our planetary neighborhood. Solar flares are extremely powerful bursts of electromagnetic radiation that can last from minutes to hours. They occur when there's some magnetic disturbance in the Sun. Then, magnetic field lines in the atmosphere of our star get tangled and snap. This releases giant amounts of excess energy, including ultraviolet radiation and intense X-rays. These twisted lines appear in sunspots. Those are darker and cooler regions on the surface of the Sun. They form when magnetic fields that used to hide deep within our star rise up to the surface. As for coronal mass ejections, or CMEs, which are launched by solar flares, they're sent outward into space. They hit planets, satellites, and basically any objects in their path. Those that come across Earth trigger geomagnetic storms, which in most cases result not only in beautiful auroras, but also in power grid failures and satellite malfunctions. All these extreme solar phenomena, CMEs, sunspots, and solar flares, get much more intense during the peak of the sun's 11-year-long activity cycle. It's known as solar maximum. Right before this event, the sun steps up its activity. It starts to spit out giant blobs of fiery plasma, emits powerful streams of radiation, and grows planet-sized spots. At first, experts were sure that the current solar cycle would reach its peak in 2025. But judging by recent numerous sunspots, intense solar storms, and some other rare solar phenomena, solar maximum is likely to arrive sooner than that. This planet is as light as a piece of fluff stuck to your jacket. In the scientific world, its name is WASP 193b, but we'll call it the Cotton Candy Planet. It's located around 1,200 light-years from us. We'll never see it with our own eyes, but scientists say the Cotton Candy Planet is pretty much Jupiter's bigger, bouncier cousin. It has an extremely low density. Combined with other factors, like its high temperature and the infrared brightness of its host star, it makes it special. Interestingly, the planet's radius is just 1.46 times the radius of Jupiter, but its mass is a mere 0.139 times of our gas giant. May I have a close-up here, please? Thank you. See how fluffy it is? It would be absolutely impossible to stand on its surface should you ever reach this distant world. It's not often that you can meet something like WASP 193b at a planetary party. Such planets are rare. Their fluffiness might be caused by their planet stars. Those heat them, puffing them up like a marshmallow that's seen too much campfire action. The planet's super low density makes it a real anomaly among those 5,000-plus exoplanets we have already discovered. The only life that we are certain about so far in the entire universe is on planet Earth. Whether that life is intelligent is, let's say, arguable. But anyway, it's not surprising that we're tirelessly searching for life on other planets. So far, they've discovered more than 4,000 of them. But what's even cooler? NASA has compiled a new list of 24 planets that aren't just Earth-like, they're better. The conditions on them are so good that they're more comfortable than on our planet. So let's examine some of them. KOI 5715.01. Let's be coy, shall we? This wonderful planet is in the constellation Cygnus. And why is it so wonderful? Well, our sun is a yellow dwarf. And sorry, sun, even though you're not bad at supporting life, there are some stars that can do it better. Nothing personal. The planet KOI 5715.01 orbits near an orange dwarf. Orange dwarfs are stars slightly smaller than our sun and have a little lower luminosity. Did you like the alliteration there? Anyway, don't worry, it doesn't mean we're going to live in complete darkness. In fact, if the planet is found closer to the sun and it has a thicker atmosphere, it may even be lighter and more colorful than on Earth. Now, our sun has a very short lifespan. Right now, it has 7 to 8 billion years left to live, a little longer than Earth's age. But orange dwarfs can live from 45 to 70 billion years. This is great not only because we'll be able to hang out on this planet longer, but also because the planets around these stars have more time to form life. Now, ideally, we would need to find a planet next to an orange dwarf that is about 7 billion years old. It's very likely there will be at least some organisms there. KOI 5715.01 is about 5.5 billion years old. Yeah, it may not seem mature enough, but that's okay, neither do I. Our Earth is a billion years younger, and that didn't stop us. The planet is quite close to its star and is in a habitable zone. 1 year there lasts 190 days. Imagine going to elementary school and already getting a driver's license. It's almost 2 times larger than the Earth. The average temperature there is 52 degrees Fahrenheit, which is slightly less than ours, 57. But it mostly feels warmer there because strong gravity helps it hold on to heat in the atmosphere longer. It's a little too far away though, like 3,000 light-years from Earth, which is about 18 quadrillion miles. Yep, better bring a really big lunch with you. KOI 3010.01. This planet is found next to the star KOI 2010. This planet sounds like a very pleasant world. The average temperature on this planet is 67 degrees, so a little warmer than ours. But that's a good thing. Scientists believe that on a perfect planet, the temperature should be just about 10 degrees hotter than on Earth. The more heat there is on the planet, the more comfortable it is to live there. Also, the higher chances of developing life. The radius of this planet is nearly 1.5 times larger than Earth. There's some atmosphere, although we're not yet sure about its composition, but it's probably like the Earth's. Scientists think that we'll find an ocean there, and it can cover up to 60% of the surface, which is also cool. In a perfect world, water and land should be distributed more evenly than on our planet. A little more land means a little more territory and resources, right? But listen, this planet is actually very similar to the Earth. The semblance is so striking that scientists believe we have an 84% chance to find life there. Of course, not necessarily an intelligent life, but at least some animals. Wouldn't that be cool? Now, what do you think they could look like? Very Earth-like planet, but with stronger gravity. Well, if someone lives there, they're probably big but have a small height and strong little legs. Sounds adorable and scary. But we won't be able to find out the truth anytime soon. So far, for us, these planets are microscopic dots in space. We only have some dry, boring data about them and don't even know what they look like. We'll have to wait until we can find a way to get closer to these planets. Kepler 186f. This is also one of the best candidates for having life. This rather cute planet was nicknamed the Earth's cousin because it does have a strong resemblance. Anyway, these two planets are like sisters, not twins. Kepler 186f rotates near a red dwarf. Red dwarfs are stars even dimmer and smaller than orange dwarfs. Yeah, they'll also live for a very, very long time, but their luminosity is also quite low. However, Kepler 186f is closer to its star than we're to our Sun, so it shouldn't be too dark there. Well, at least not night-like dark. The sky on this planet is sure to be an unusual shade of red, like sunsets on Earth. What do you think? Would you like to live on a planet with an eternal sunset? The size of this planet is about the same as Earth. Not bad, not perfect. Why so? Because the coolest planets are those that are bigger than Earth and have stronger gravity. Now you'll probably say, but wouldn't it be harder to walk there and even harder to get out of bed on Monday? Of course. But on the other hand, this planet will pull the atmosphere better. The atmosphere will be thicker and denser. This means more protection from the scary space stuff, more oxygen, and more heat. Not to mention the fact that the bigger planets have more space to settle. Awesome, right? But of course, the Earth's size is also an excellent choice. Another cool fact is that the tilt of Kepler 186f is about the same as ours. It means that there should be stable seasons and a normal day-night cycle. Do you know how important the tilt of the planet is? Let's look at Mars. Mars is also, in fact, found in the habitable zone of our Sun, but its tilt is very unstable, and as a result, the entire ocean that could have been on it once now completely dried up. Today, it's just a red desert, and there's no life there. At least not as far as we know, but you see how important these tiny details are? This planet is also quite far away from us, 490 light-years. That's about 3 quadrillion miles. So yeah, we're just going to keep waiting for intergalactic travel. Kepler 62e and 62f. These planets were called the most Earth-like before we discovered Kepler 186f. They're very comparable to our home. Kepler 62e is about 1.5 times larger than Earth, and Kepler 62f is just slightly smaller than that. They're located in the constellation Lyra, which is about 1,200 light-years away from us. They both also orbit a red dwarf. 1 year on Kepler 62e lasts about 122 days, even less than on that first planet we talked about. Scientists believe that both 62e and 62f are sort of water worlds, warm places mostly, or even completely covered with water. If there is land there, it's probably just some islands. A world consisting entirely of islands. A fantasy dream for some, think Hawaii, and a nightmare for others, think Megalodon. But if you're a fan of ancient marine animals, just imagine how gigantic they could be there. Still, there are many things we don't know about this planet. Does it have a surface? What about its composition, density? One day, maybe we'll be able to answer these questions. And so, that's it for the super Earths. Of course, the original list is much longer, and you can go check it out on the internet. Now, the best thing about all this is that these are planets that are better than the Earth. But we also know thousands of other exoplanets that are just close enough to ours. And the odds are, a few of them have at least some form of life. But they're very, very far away, so we have no way to check it out right now. Perhaps, down the road, we'll find some cool creatures on many of them. Strange explosions in vibrant blue colors are popping up around the universe and keeping astronomers intrigued. This rare and incredibly powerful event has a fancy name: luminous fast blue optical transient. This phenomenon doesn't behave like anything else we know of, and things got even stranger when the most recent one happened in a spot it shouldn't have. To really understand what happened last year, we need to go back a bit. This type of strange explosion was spotted first in June 2018. The blue blast happened about 200 million light-years from Earth and got the nickname the Cow. No, this happening didn't resemble a cow at all, but it did have an unusual format. Back then, this blast was the most asymmetrical explosion ever seen by astronomers. It burst into space in a flattened pancake-like shape, not in a typical sphere as they would expect. This phenomenon was similar to a supernova, which is the most common type of cosmic explosion that happens when a star exhausts its nuclear fuel and collapses under its own gravity. However, scientists also noted 3 crucial differences. Number 1, this phenomenon is more powerful than a typical supernova. When it happens, the blue burst emits more energy than an entire galaxy of hundreds of billions of stars like the Sun. Number 2, it's much faster. The explosion reaches its peak brightness and fades away within a matter of days, while a supernova can take weeks or even months to completely dissipate. Then the last difference, these blue bursts can also be much brighter. These mysterious objects are considered the brightest known optical phenomenon in the universe. But unlike a regular supernova, it's believed that there are no radioactive elements to power this brightness. So that means the power must come from somewhere else. The question is, from where? This is just one of the mysteries that the scientists are trying to figure out. There have been some heavy investigations since the event was first observed, and 15 telescopes around the world are constantly looking for it. Since 2018, these extreme explosions have been spotted about once a year. So while they're rare, they're not incredibly uncommon. There are several possible explanations for the existence of these fast optical transients. Perhaps the most acceptable one is that it is a stellar corpse. I mean, what is left behind when a star calls it quits. So we're looking at 2 prime suspects here. They could be a neutron star or a black hole, producing emissions close to the speed of light. The theory goes like this. There is a massive star much larger than those that produce regular supernovas. Then it starts to collapse. Such an event would certainly be expected to leave a black hole behind. Let's say this massive star isn't ready to leave the universe in a quiet way. Instead, it creates a swirling disk around the black hole composed of gas, dust, and other matter, like it matters. This disk, called the accretion disk, can shoot out streams of material at incredibly high speeds, almost like powerful cosmic jets. and that could be exactly what we see as those sudden bursts of light. Again, it's just a theory. What exactly sets off these blasts remains a mystery, and much more observation and analysis are needed. Experts believe that explaining such an oddity is a scientific goldmine. After all, we're talking about a stellar corpse that isn't just sitting there, it's actually quite active. Now, since this event was first spotted, all similar occurrences that our telescopes have captured happened in the same place. I mean, the explosions always occurred in the spiral arms of different galaxies. But last year, things changed. The Hubble Space Telescope left scientists speechless in April 2023 when its images caught this same type of weird explosion happening for the first time in the middle of nowhere. Well, it didn't happen inside a galaxy as it was supposed to. It happened in the space between two of them. More precisely, about 50,000 light-years from a large spiral galaxy and about 15,000 light-years from a small one. This event is known today as the Finch. Oh great. So when we finally get closer to finding some answers, the unusual location of the Finch phenomenon came to mess it up again. So maybe there is another explanation for it. Speculation began soon after the discovery. One idea is that it could have been a collision between two neutron stars traveling far outside their host galaxies. These two could have been spiraling toward each other for billions of years, and when they collided, they produced a flare over 100 times brighter than a normal supernova. For this hypothesis to be correct, one of these neutron stars would have to be highly magnetized, amplifying the explosion. Another possibility is that the explosion was a star being torn apart by a black hole with a mass between 100 and 1,000 times that of the Sun. Although we still have lots of questions, one thing is for sure. The Finch is a luminous, fast black optical transient. Except for the weird location where it happened, it has all the other characteristics to be classified as one. It's super bright, like me, and super fast, and its origin is super hard to explain. Plus, the data from the Gemini South Telescope, the Chandra X-ray Telescope, and the Very Large Array Radio Telescope have confirmed it. Adding this latest information only makes it harder and harder for researchers to finally find some kind of pattern in this whole event. The Finch isn't the only peculiar event in this category. Let's head back to the year before, to 2022. A blue explosion was spotted in September, and it got the nickname of Tasmanian Devil. Just like the previous ones, this blue burst came up and disappeared very quickly. Then, something mysterious happened. Exactly 100 days later, observers who were still tracking the phenomenon got an early Christmas gift. They observed another flare-up, and it was as bright and fascinating as the original one. Wait, so we're talking about two similar and strange explosions that happened at the same spot and close in time? Well, this was a first. Quickly, 13 telescopes around the globe all had eyes turned toward the Tasmanian Devil event, including one equipped with a high-speed camera. Over the course of 120 days, they managed to capture another 14 irregular light pulses. This was certainly amazing because it proved that instead of showing up once and fading away as expected, the Tasmanian Devil continued to explode with supernova-like energies again and again and again. Can you imagine such power? This scenario still intrigues the scientific community because it pushes the limits of physics, not only because such extreme energy production, but also because of the short duration bursts. By the way, its flares last from 10 minutes to about 4 hours. Believe me, on the scale of the universe, that's considered super quick. This was the only time that an extended season of this event was observed. However, after some thought, the scientific community split their opinions about it. On one hand, the Tasmanian Devil could have been an utterly unique and one-of-a-kind event. On the other hand, maybe it was just the first time that our telescopes caught it from a more face-on angle. To further understand what's happening, scientists still need to observe larger samples of the phenomenon. All hopes are in the upcoming Vera C. Rubin Observatory, which is currently being constructed in Chile. It will have a 27.5-foot wide telescope, coupled with the world's largest digital camera ever fabricated for this purpose. According to NASA, this technology might finally give us some answers about these blue explosions. We can expect some exciting times ahead, as this could be the start of a new chapter in our understanding of stellar evolution. Ruh-roh, there might be another universe, like a dark mirror image of ours, where time flows in reverse. This flipped-over world might also be the source of dark matter, the invisible substance that's all over our universe. There might also be many more universes out there, in which an exact copy of you woke up this morning, but it chose a white t-shirt instead of a red one, sending it on a completely different life path. But let's start with this elusive dark matter. It makes up most of the universe's mass, yet we're not sure what exactly it does or where it comes from. That's because it doesn't act like regular matter. We can't see it or feel it. We just know it's there because of how it seems to bend gravity. Even though regular matter and dark matter are very different, they seem to exist in a balance. Some scientists think this must be connected somehow. A new theory suggests that for every way regular matter moves, there's a mirror version of it in the world of dark matter, like a bridge connecting the two worlds. There's also a strange coincidence in regular matter where a neutron and a proton have almost the same weight. This allows them to stick together and make atoms stable, making everything that we can see with our eyes exist. If protons were a bit heavier, there would be no balance and atoms wouldn't form. In the dark mirror universe, maybe things happen differently. Maybe in there, the equivalent of a proton doesn't bind to other particles, leaving behind lonely neutrons, which could be the source of dark matter. This theory also suggests that dark matter might have its own chemistry, like dark atoms and a dark periodic table. For the longest time, scientists believed there was just one type of dark matter. Although these particles are similar in some ways, like being almost invisible, they may vary in their sizes, speeds, and how they affect regular matter. If this idea is right, it means there could have been interactions between our universe and the dark mirror universe in the past. Studying how elements formed in the early universe might give us clues about this. The idea of a flipped world has sparked curiosity and even some confusion in the scientific community in recent years. Astronomers use a theory called the Lambda CDM model to explain the composition and behavior of our universe. According to it, most of the universe is made of two things: dark energy and dark matter. Dark energy is like the pushing force that makes the universe expand faster. Dark matter is this invisible thread that pulls things together with its gravity, acting like a universal glue. Regular objects, like stars, planets, and comets, only make up a small part of the mix. The model also tells us about the Big Bang, and how everything started from a hot, crowded beginning, and how the universe has been growing and changing ever since. While this model seems to be correct in many ways, it doesn't explain all cosmic phenomena. If you were to draw this model on a piece of paper, it would look like a series of flat pancakes stacked on top of one another. Each one of the pancakes represents a rendition of the universe at a certain point in time. Yesterday's universe would stand below that of today, but it would be a slightly smaller pancake. By the end, you'll see that the universe's history looks like this giant upside-down cone, with its minuscule tip being the Big Bang. Beyond this point, we can't see any further away in time with the tools we have, so we don't know what's beyond. More so, we're still not even sure what happened immediately after the Big Bang. But if we simply apply the math, the universe might go beyond this historical tipping point, which could mean it could go in reverse. creating a similar mirrored cone where time would flow backwards, in our perspective at least. This alternative idea not only challenges our understanding of cosmic origins, but also raises questions about fundamental principles in physics. All the excitement around a mirrored universe also came from ANITA, a scientific instrument stationed in Antarctica, and its discoveries. This device saw some weird high-energy particles seemingly bursting from beneath the Antarctic ice. The problem with these particles is that they didn't behave as the laws of physics dictate. Scientists think they have a type of cosmic rays. They travel from space through the Earth and back out again. But the particles we already know about shouldn't behave like that. That's because higher energy particles usually collide with something inside the Earth and don't come out the other side like these do. They seem to be doing things both forward and backward. For now, there's no concrete proof of a mirrored universe. These particles could simply be ones we haven't discovered before, and scientists need to study them closely to come up with a definitive answer as to why they're behaving like this. Kind of like 4-year-olds. But what if there isn't just one other universe, but many more? This multiverse concept comes from ideas like the inflation theory, which says that our world had this rapid expansion in its early stages. While inflation stopped in our neighborhood billions of years ago, it's likely that it continues in other regions of the multiverse, creating different universes with their own laws of physics and unique characteristics. Our universe is the only one that we know of that can support life. We have stable stars that can provide heat and warmth, for example, which is crucial for creatures to start moving around. We also have an abundance of elements like carbon and hydrogen, which we also need to exist. The multiverse hypothesis gives an explanation for why our universe exhibits such life-friendly conditions. It may explain that there are countless other universes out there, with varying conditions, making the existence of life in at least one of them less likely. One fascinating implication of the multiverse theory is the idea of doppelgangers, these exact copies of individuals existing in parallel universes. This notion suggests that within the vast expanse of the multiverse, there could be infinite scenarios where identical versions of ourselves are experiencing similar events at the same time. Before we begin our travels to different universes altogether, we might need to understand our own. There's this galaxy, for instance, far from us, that might have no dark matter at all. It's about 250 million light-years away and looks normal at first glance. But if we look closer, we can't seem to find any dark matter. If it turns out that there are more galaxies like this one, it could change our ideas about how galaxies are made. Dark matter is usually thought to be necessary for this process, acting like the glue that holds the whole thing together. It is true, however, that this particular galaxy is more faint and has fewer stars than usual. When it was first discovered in 2019, scientists thought it might not have dark matter because of how fast it was spinning. The speed at which a galaxy spins tells us how much stuff there is in it. By comparing this speed with what we can see, astronomers can figure out how much extra stuff, like dark matter, must be there. And in this unique galaxy, the math says there isn't any. Among all these theories, there's also one that says dark matter might not be real at all. This new study proposes that maybe we've been looking for something that doesn't even exist. They think that our understanding of gravity might not be good enough to explain why some galaxies behave oddly. So instead of dark matter causing these weird behaviors, they say it might just be that we don't fully understand how regular matter works. They base these findings on a theory called modified Newtonian dynamics. It suggests that gravity behaves differently at very large distances or very low speeds.
The moon is rusting, and chances are it's happening because of Earth. You'd say that since they're more than 230,000 miles apart, they can hardly directly influence each other in such a way, but they do actually have a special connection. The moon affects our home planet as well, and you can see it while observing ocean tides. As Earth rotates, the moon's gravitational force pulls the water on the nearest side of Earth. It creates a bulge. At the same time, another bulge forms on the opposite side because our planet rotates and it causes a centrifugal force. And then the planet continues to rotate underneath these bulges, which is why we have 2 low and 2 high tides every day. Plus, the moon wobbles every now and then, tilts more or less, and causes changes in ocean tides. And in return, Earth's atmosphere is making our satellite rusty. Rust is that reddish substance you see on old gates or nails. Oh, and you know Vermilion Cliffs and the Grand Canyon? They also have that specific red color, thanks to rusty iron in the rocks. It forms when iron reacts with oxygen and water. Rust is common even on Mars. The planet's trademark color comes from the rust that's been there for a very long time. That's how the red planet got its nickname in the first place. Normally, you wouldn't say the moon is a place that would rust that easily since it's dry and doesn't really have an atmosphere. But a spacecraft studied the moon back in 2008 and detected spectra, wavelengths of light, that were reflecting off different surfaces of the moon. That's why it could analyze the lunar surface better. The data it brought showed that the lunar poles had different compositions than the rest of the moon. They had rocks that contained a lot of hematite. That's a specific type of iron oxide, or simply rust. No one expected that because there shouldn't be so much rust on the moon, considering the conditions there. But we know that there's some water up there on the surface of our satellite. That's why a few new theories popped out about different materials the moon could be hiding. It's possible that they formed because water had reacted with the rocks. For iron to get this rusty hue, it needs something we call an oxidizer. That's a molecule that removes electrons from materials like iron, such as oxygen. But the solar wind keeps hitting the moon all the time, and it brings hydrogen with it. And hydrogen has the opposite effect. It gives electrons to other molecules. Earth has its shield from the solar wind. It's our magnetic field. But the moon doesn't have such protection, and because of that, rust shouldn't be able to form on its surface. But this process still happens, and it could be Earth's fault. The moon itself doesn't have an atmosphere that could provide enough oxygen for iron to rust. But apparently, our planet is generous enough to donate some of its own atmosphere. The oxygen from our atmosphere travels all the way to the moon, following something called magnetotail. That's a long extension of Earth's magnetic field, which can reach the near side of the moon. That's exactly where most of the hematite was found. And during a full moon, the magnetotail blocks 99% of the solar wind, which would normally influence the moon more. It's like there's a temporary curtain over its surface, which gives enough time for rust to form. But there's still one important thing necessary for the appearance of rust: water. It's not like you can find water that easily if you decide to take a walk across the moon. Most of it is frozen and hidden in areas that always remain in cold shadows. Those spots are far away from where most of the hematite was discovered, so it's hard to tell how the water got there. But there's an interesting idea. All those dust particles that hit the moon might be freeing free molecules of water that are locked in the surface layer of the satellite. This is how water ends up mixed with iron. We don't know exactly what these dust particles consist of. They might be carrying some water too. As they hit the lunar surface, this might create heat, which boosts the oxidation process, and more rust forms. So, our planet does certain things that change the moon, but humans do the same. A probe that landed on the lunar surface back in 1959 was the first human-made object that touched the moon. That's also when we started altering the moon in unpredictable ways. Scientists call this the lunar Anthropocene. It's like an analogy with Earth's Anthropocene, a period when human activity made an impact on the planet. It's not like we can choose a certain starting point when such an activity began. But we now know that things we have done over the history of our existence have really changed the environment of our home planet. We don't have any people living on the moon yet, but we've already left some traces there. After humans first came to the moon, we've had many missions there. We left some landers and flags, moved lunar soil, brought golf balls, scientific equipment, and even some human waste. Plans for the future? Send more missions up there and even potentially create an infrastructure where some of us could live, study the moon's resources, and send them back to Earth. That's why it's important to talk about the lunar Anthropocene to remind ourselves we have to be responsible and take care of our heritage. Many people are confused about why we sometimes see the moon during the day. Some even believe it's something new that didn't happen before, especially after they started sharing a low-res picture of what looks like a full moon in the middle of the day. Some have pretty unusual ideas that the sun isn't the same color as it was before either. Allegedly, it used to be more yellow. The sun hasn't changed its color. It's still blue-green. But it's possible that we saw it as more yellow when we were younger because before, pollution wasn't as bad. And when it comes to the moon, we can see it both at night and during the day. It's brighter at night because there's no light coming from the sun. But it's not like it goes anywhere during the day. It's still there, but we just don't see it during the new moon phase. That lasts a couple of days, and during that period, the moon comes pretty close to the sun. The scattered light coming from the sun makes our satellite less visible to us. Speaking of the moon phases, they're easy to recognize when you know what to pay attention to. First, there's the black moon, which can mean a couple of things. One definition says that it occurs when we have 2 new moons in a month. Another one claims that the black moon happens when there's no new moon in a month, and that only happens in February. A blue moon is not called that because of the color. It's the 3rd full moon in a season that has 4 full moons. And a supermoon occurs when a full moon coincides with the moon's closest approach to Earth in its elliptical orbit. That's why it looks bigger than usual. Sometimes you can look up to the night sky and see an eerily red sphere up there. It's not about signs that tell us that the end of the world is coming or that werewolves are roaming around. But yep, blood moon is a good inspiration for stories like that. In reality, it's just an astronomical event when our planet casts a reddish shadow on the moon. And that happens when Earth comes between the moon and the sun, which is called a total lunar eclipse. Earth's little companion catches some red light coming from our atmosphere, and that's why you see that specific color.
We still can't find the source of the mysterious signal we've been receiving since 2018. We receive it every 22 minutes, and nothing can explain this. Some scientists even believe it could be coming from another civilization we haven't met yet. This strange radio signal wasn't found by a scientist on a serious mission. It was actually discovered by a college student just doing a regular project for school. Tyrone O'Doherty, an undergrad student at Curtin University in Australia, was sifting through old data of the southern sky. He was looking for any weird blinking radio signals. He finally stumbled upon one from 2018 that seemed to shoot radio waves towards Earth like a lighthouse beam. Excited about his find, Tyrone shared it with his mentor, radio astronomer Natasha Hurley-Walker. She dove into researching this signal, hoping for a breakthrough. But despite checking different frequency data, they hit a dead end. But then, Natasha spotted a pattern. The signal repeated every 18 minutes. This was huge. But just as they were gearing up to study it further, poof! The signal vanished after only 3 months, leaving them with nothing. Not giving up, Natasha and her team scanned the skies again, desperate for a clue. Months passed, but nothing turned up. They were ready to give up, and then suddenly, a new signal popped up. This one kept blinking for 5 minutes, then it disappeared. and then it came back exactly 22 minutes later. The main question was if that signal was related to an 18-minute one. To figure it out, Natasha went back to the old radio data from that area. As they dug deeper, they realized that yes, and these signals aren't anything new. They'd been beaming towards Earth for 35 years. Back in 1988, Indian and American telescopes had caught them, but they got buried under tons of other data. This was great news for space explorers because it meant they could now calculate how far away this mysterious object was. After doing the math, they figured out it was incredibly far, even on a space scale, 15,000 light-years from Earth. Now, the only thing left to uncover was what exactly this object was. Walker and his team started comparing it to all the known radio-emitting objects out there, yet its source remains a mystery. The signals still pop up every 22 minutes on NASA screens, always ending with a frustrating match not found message. The scientists called it J183910. Some think that the signal might come from some extraterrestrial beings. Maybe it's the signal that SETI, the search for extraterrestrial intelligence, has been waiting for. This project has been working for over 50 years, trying to find any evidence of life beyond Earth. They also scan the skies for radio waves, laser pulses, and other mysterious signals. So maybe it's a way for extraterrestrial folk to communicate their location. While that idea may sound exciting, we need to be careful about jumping to conclusions. First, we don't have solid proof for that. Before any concrete evidence, it's just speculation. And also, there are other more plausible explanations. Most likely it comes from a natural phenomenon, and there are a couple of theories for that. The first one is the pulsar theory. Imagine a huge star in space much bigger than our Sun. Sometimes these big stars finish their life journeys in a spectacular event called a supernova. When this happens, the star's core collapses, becoming super compact, as if you're squeezing all the stuff from that star into a tiny space. That tiny, super-dense core is called a neutron star. Some of these neutron stars are extra special. We call them pulsars. They get their name because they seem to pulse with energy, like a space lighthouse. These pulsars have incredibly strong magnetic fields, much stronger than what you'd find on Earth. They're like enormous magnets in space. Because of this, they shoot out beams of energy. They're also spinning super fast, so these beams of energy seem to pulse on and off as they spin around. Now, the strange signal we detected seems to have similarities with pulsars, but not quite. Pulsars usually have a predictable lifespan and slow down over time, eventually stopping their radio signals. In contrast, our mysterious signal is quite persistent and is blinking beyond what's expected for pulsars. So, maybe it's not a typical pulsar, or not a pulsar at all. There's also a magnetar theory. Now, a magnetar is another type of neutron star. They're like supercharged versions of pulsars, with even stronger magnetic fields and slightly longer pulsating periods. Maybe this is what causes our signal's intense persistence. However, when we plotted the data, we also realized the signal didn't match the magnetar's vibes either. Magnetars not only send out radio waves, but also powerful X-rays because they're so energetic. But the signal we received was only sending out radio waves. So we figured it's not a pulsar and not a magnetar. The signal's behavior is very strange and suggests an unnatural source. This means there might be something in the universe that scientists haven't fully explored yet. And there is a space object that we don't know much about. The final theory is the so-called dwarf pulsar. Sounds a little dopey to me. Couldn't help myself. Now, a dwarf pulsar is like a star that blinks with light flashes, similar to pulsars, but it takes longer for each blink. Usually, white dwarfs are the leftovers from smaller stars. They don't blink because their magnetic field isn't as strong as pulsars. But when a white dwarf becomes pretty hefty, almost the mass of our Sun, it gets super dense and starts pulsating with a strong magnetic field, just like pulsars. They have a cool quirk. White dwarfs are made of electrons, not neutrons like pulsars. When these charged electrons start dancing with the magnetic field, they shoot out periodic light flashes, which happen every 100 to 1,000 seconds. As you remember, our signal has a period of 22 minutes, 1,320 seconds, a bit longer than the usual white dwarf pulsars, but it's much closer to the truth. So far, this sounds like the most plausible explanation. But even this theory isn't fully confirmed yet. This just shows how much there is in the universe that we're still figuring out. For example, fast radio bursts, another mysterious type of signal we've been detecting. They're like quick, intense bursts of energy in the form of radio waves. They have a ton of energy. FRBs are so powerful that sometimes they can be brighter than entire galaxies. Now, imagine this. They release as much energy in a few milliseconds as our sun does in 3 whole days. Wow! These bursts happen all over the sky with huge frequencies, although some have been detected with lower frequencies. Every day, we catch around 10,000 random FRBs in the sky. Some of them repeat, but most happen once and disappear forever. Unfortunately, most of them only last for a fraction of a second, and by the time their energy reaches us, it's 1,000 times weaker than a mobile phone signal from the moon. This is why, despite their brightness, there's still a lot we don't understand about them. We're still trying to figure out what causes these FRBs. They could be coming from different sources, like already mentioned magnetars, colliding stars, or even merging galaxies or white dwarfs. As these bursts travel through space, they pick up information about the cosmic environments they pass through, like interstellar gas clouds. It's very unlikely that FRBs are some messages from extraterrestrial beings, though. Not only because there are thousands of them every day all across the sky, but also because we know that the sources of these bursts must be incredibly energetic themselves. Our neighbors would have to have equipment stronger than entire galaxies for that. But the bottom line is, while all these signals are fascinating, there's still a ton to learn about them.
Prepare for blastoff, because there's some exciting news from NASA coming our way. Care to look into the fascinating world of Saturn's moon, Titan? NASA's groundbreaking Dragonfly rotorcraft lander is set to take off in 2027, looking to explore this mysterious space object. Now let me introduce you to Titan. It's an icy celestial body with an atmosphere filled with nitrogen, and it might even have an underground ocean. Titan is also home to rivers and lakes that flow on its surface. But guess what? They're not filled with water like our lovely planet. They have methane instead. Now let's check out Titan's celestial credentials. It's not just any moon. It's the second largest in our entire solar system. It's only 2% smaller than the biggest moon we have hanging around our neighborhood, which is Jupiter's Ganymede. Titan's size even puts Mercury to shame. And did I mention that its atmosphere is 4 times denser than that of Earth's? Thanks to Titan's lower gravity and thick atmosphere, Dragonfly is the perfect robotic companion to uncover its hidden treasures. Let's move on to Dragonfly, the star of NASA's upcoming mission to Titan. This cosmic drone is not your average explorer. Equipped with a full array of interesting gadgets, Dragonfly is like a flying laboratory, ready to uncover more secrets of Titan. It's the first interplanetary rotorcraft lander probe, designed to take us on an epic journey of discovery. And don't let its name fool you. Dragonfly won't just buzz around aimlessly. This technological marvel is able to glide for several miles between different locations on Titan's surface. Think of it as a cosmic Uber service for scientists. And speaking of technology, Dragonfly is carrying some seriously cool equipment. It'll feature the Drill for Acquisition of Complex Organics, DRACO, instrument, which will help us scoop out material from Titan, while the Dragonfly Mass Spectrometer, DRAMS, will analyze what these samples are made of. But how did we stumble upon Titan? It was March 25th, 1655, when a Dutch astronomer was out there with his telescope exploring the cosmos. Lo and behold, he spotted something amazing. It was Titan, the biggest moon of Saturn. Fast forward almost 300 years to 1944, when another cool astronomer jumped into the picture. He was doing some experiments with light when he figured out that Titan actually has its very own atmosphere. There's more to this story. In 1979, the Pioneer 11 spacecraft decided to take a joyride through the Saturn system. It confirmed all the cool things scientists had previously speculated about Titan, like its temperature and mass. However, there was one tiny mistake. Those sneaky scientists thought Titan might be the biggest moon in the entire solar system. Oops, wrong guess. Nevertheless, Titan had this mysterious, dense atmosphere that kept everyone on their toes. Now let's zoom in on the 1980s, when the Voyager 1 and 2 spacecraft make their grand entrance. These cosmic explorers flew past Saturn, and they wanted to get a good look at Titan's surface. That's when Titan decided to play a game of hide-and-seek with them. Its hazy atmosphere made it impossible to see what was going on down there. So all the Voyagers managed to capture were images of a lonely orange world. However, they did spot a fancy blue haze hanging out in the upper atmosphere. Things started to get really exciting in the 1990s. The Hubble Space Telescope joined the party and decided to take some cool snapshots of Titan using special infrared light. This clever device managed to pierce through the haze, and voila! The Hubble images revealed differently colored areas on Titan, almost like a giant cosmic chessboard. We now know that there's even a bright spot as wide as Australia down there. However, despite these fantastic pictures, the mystery of what lay beneath Titan's haze was still unsolved. It was 2004 when the stage was set for Cassini and its European sidekick, the Huygens probe. They were like the ultimate dynamic duo, ready to take on Saturn. Cassini started orbiting the ringed planet and immediately focused its attention on Titan. The big moment finally arrived. On January 14, 2005, the Huygens probe pierced through Titan's atmosphere. During its descent, Huygens collected all sorts of amazing data, snapping images and analyzing the atmosphere. The probe then transmitted this valuable information back to Cassini, which, like a cosmic courier, sent it to us eagerly waiting Earthlings. Over the next 13 years, Cassini flew close to Titan over 100 times, using all sorts of fancy instruments to get a good look at the moon's surface and atmosphere. Scientists could finally confirm that Titan had clouds, lakes, and rivers, and there was also some rain pouring down its surface. Thankfully for us, Titan isn't the only moon in our solar system that could technically harbor life. Take the wondrous moon of Neptune called Triton. For starters, it's the largest moon of Neptune, but it's also a real oddball. Among the many moons out there, only 5 are known to be geologically active. And guess what? Triton is proudly part of this exclusive club. It loves to show off its geysers, which spew nitrogen gas. Picture Triton as a fashionista in an icy ensemble. Its surface is mainly frozen nitrogen, giving it a chill, frosty vibe. You might want to bring a warm coat if you ever visit. Now, you may be wondering how Triton manages to keep warm in such a frigid environment. Well, it's got a secret weapon called tidal forces. Imagine Triton and Neptune engaged in a cosmic dance, creating gravitational friction. This dance seems to generate some heat, helping to warm up Triton's waters. With all this talk about heat, you might be getting excited about the possibility of life on Triton. However, finding life on this moon is about as likely as finding a unicorn riding a skateboard. Voyager 2, the only mission to ever fly by Triton, made its journey back in 1989. And if you're hoping for another mission to Triton anytime soon, well, let's just say the stars aren't aligning in our favor. Literally. The window for a mission to Triton opens up only once every 13 years, because our planet and Jupiter need to be perfectly aligned for the landing to work. Scientists would use the gravitational pull of the largest planet in our solar system to safely deliver a probe on Triton. Now, let's address the elephant in the room, or should I say, the polar bear. It's so cold on Triton that hopes for life to survive unfrozen are about as slim as a toothpick. Sorry, potential little microbes. You might need a few extra sweaters to set up shop down there. Even though Triton may not be the most welcoming place for life, it's still a celestial gem worth exploring. Scientists also believe Triton wasn't always a part of Neptune's crew. As it turns out, Triton was most likely just minding its business, hanging around aimlessly in the distant Kuiper Belt. Along came Neptune with its mighty gravitational pull and snatched Triton right out, officially making it a moon of its own. Just like our trusty satellite, Triton is also stuck in a permanent face-off with Neptune. One side of Triton always has its eyes locked on the planet. As for this amazing moon's fate, things aren't looking so good in the long run. It's already getting closer and closer to Neptune every day. Why is that, you might wonder? The problem is with those tidal interactions, which are playing some cosmic tricks on Triton. They're causing its orbit to wither away, like a slow-motion dance towards Neptune. Scientists predict that in about 3.6 billion years, Triton will cross an invisible boundary. If these current calculations are correct, there are two possible scenarios. It'll either have a collision with Neptune's atmosphere, or it might just break up into tiny pieces. If the latter happens, an all-new ring system would form around Neptune, just like the one we see around Saturn nowadays. Triton is not the only satellite that might end up this way. Phobos, one of the Martian moons, is likely to disintegrate too, and sooner, in 30 to 50 million years.